All right, let's get started. So once again, thank you for joining me today. My session is about Flex Consumption, which is a new hosting plan that we are bringing out for Azure Functions. And I'm Thiago Almeida. I'm a program manager on the Azure Functions team, and working on Flex Consumption has been one of my key focus for the past year or year and a half. And I'm really excited to introduce you to you all. I have a lot of content, so I'm glad that I have a full hour to go through everything with you. But I'm happy to take questions, closer to the end or throughout if you need to. Okay, so just a reminder, if you haven't yet, that barcode gives you access to an app for the conference that you can then give session reviews. I'd love to hear from you what you think of the session and the conference overall. So I have another print screen at the end, but you probably saw the rest yesterday as well, so you might have the app already. Okay. So let me go back. Just a quick reminder, I don't want to go too much into it because I hope you already know about Azure Functions, but I see Azure Functions as being two things. It's both a programming model, and that's what the integrated programming model comes from, and then the end-to-end developer experience. And that allows you to create apps, even locally, run the core tools to test it out locally, host yourself if you want to from the open source hosting plan and on Kubernetes. So that's the integrating programming model, bindings and triggers that helps you connect to different services and then execute your functions. But then on the other side, we also have a service on Azure that is the Azure Functions service with different options of hosting plans that you can run your functions on, which are, of course, the best place to run Azure Functions. And from the hosting options flexibility, we have the consumption plan, which is not on this slide. And now we're introducing a new version of the consumption plan called Flex Consumption. And I'll definitely go into much depth of what Flex Consumption really is in the coming slides. But other hosting plans that you already have and we're investing a lot on as well going forward are the app service plan. Sometimes you see it in our documentation that called dedicated. And that's if you really want to own the instances, the machines that your functions are running on, and if you want to co-locate them with web apps, or you're already running web apps and you have some extra capacity in those app service plans, you can also run your function apps there. Container apps is kind of new. It went GA in May during build. And that is if you want to bring your own container, or if you already have container apps environments that you want to run other services, microservices that you build or solutions that you build with containers, and you want to bring your own container with Azure Functions, then we have a first-party support now for running functions on container apps. So if that's of interest to you, look it up. And then finally, the premium plan, we call it Elastic Premium. And that is kind of an in-between where you get full instances access like you do with app service plans, and you can put multiple function apps inside the same premium plan, but the scaling of it will be more elastic. So it will look at the event sources and decide when to scale out and in. And Flex Consumption is kind of an in-between consumption and premium plan where it is like consumption that you have a choice of, or it is like consumption where you are built only serverlessly while there's executions in your instances, but it has some of the premium plan functionality. The key two ones are flexibility of scale. As you see, the scaling that methods that we've implemented in Flex Consumption is quite different, and it scales much faster and better than any of the other hosting plans. And also private networking. That probably has been the top requested feature for a consumption plan on Azure Functions for quite a long time. So we're happy to bring finally private networking features inbound and outbound for a serverless build plan. So let's get even further into what Flex Consumption is. The first thing that you'll notice when you create a Flex Consumption app is you will be given a choice to choose an instance size, memory-based. So it's a Linux-only hosting plan. I want to say that out of the box. But if you have a requirement for Windows, I'd love to hear from you. But for now and for the foreseeable future, Flex Consumption is Linux only, especially now that .NET 8 isolated and .NET core is one of the key .NET language versions that we're going forward with. And it also, under the hood, we're sharing the same infrastructure as container apps for the instances that run it. And so it's all containers behind the scenes. And I'll go into that a little bit further down the slides. And you get given a choice of memory. So at the moment, we have a 2 gig and a 4 gig instance size that you can choose when you create the app. We're working towards a 512 instance size as well, 512 megabytes, which is kind of a half a gig. So for example, if you have a Python app that each execution only uses a little bit of your compute needs, but you want it to scale out because Python doesn't work that well with multi-threading, then that would make sense for the half a gig one where you don't have any concurrency. Each instance only executes one function execution at a time. And I'll go into concurrency more in the next slide as well. And you can think of as, depending on which memory size you choose, then the CPU and bandwidth kind of goes along with it. So don't tell anybody that I told you, but the 2 gig one, at the moment, it has a 1 full core, and then the 4 gigs is 2, and the half a gig will have a quarter of a core. So it kind of goes that way. But at the moment, we're not documenting that just in case we want to change things at the end for the better, in case we notice that the performance expectations from you is not according to what you want or something like that. So we can always change the memory to CPU ratio behind the scenes. So once you chose an instance size, the next thing is per instance concurrency, which is a key topic for flex consumption. Per instance concurrency means that each instance of that instance size that you chose, 2 gigs, will be given only a certain number of executions or events to handle at any given time. If the event source has more than that, it'll create more instances. So as an example here, say if you have, again, a Python app, or if you have even a C# app that is very heavy, each execution uses a lot of your compute, then you might want to set concurrency to 1, and as 10 HTTP requests come, it'll scale it out to 10 instances, and each instance will be handling 1 at a time. And of course, depending on how fast they execute, they'll pick up the next execution that's coming and reuse those instances. But the platform will try to keep it at that concurrency that you set. And of course, if the execution number comes down, then it'll scale back in. Not that you need to worry too much about it scaling in, because if there's no executions, you're not paying for those instances. It's on the platform. But just, of course, we will scale your app in eventually. And again, if you set concurrency to 2, then if you have 10 HTTP requests, each instance will be given 2 executions to handle in parallel at the same time. And the other plans, Elastic Premium and Consumption, they already have this concept for non-HTTP triggers. But Flex Consumption does that for non-HTTP triggers and HTTP as well, which is quite new and something that we've had a lot of feedback from customers. Like, we had a big retailer that they had a deal with a famous person, and they were announcing a new clothesline live during their concert, and they wanted a way to ingest the interest from customers that were filling out their names and contact information, etc. They just wanted to handle a burst all of a sudden of thousands of requests per second coming in via HTTP into a third-party solution, and they had to go with multiple function apps, or they basically ended up just hosting it on Kubernetes with a pre-provisioned number of compute to be able to handle what they wanted. But with Flex Consumption, you will be able to handle that pretty well. Let me go into a demo so that you don't fall asleep too early. So I have here a function app. Let me know if that's easy to read. But it's a pretty simple function app. It takes in an HTTP post trigger, and this is meant to be receiving, say, processing customer feedback. So customers are filling out feedback online. I take in that request, and then the only thing I'm doing is forwarding that to event hubs. So as you can see here, I'm sending a return output type to event hubs, and then there's the event hub output. So basically, comes in, HTTP. You could do some processing, of course, of that, augmentation, mapping, and etc., which is the typical thing that customers do, and then sends it out to event hubs. And I've deployed the solution to Azure here, so you can see my my resource group with this solution, and I will probably go into Resource Visualizer if that makes it easier. But my function app here, it has, of course, App Insights and storage, and the Flex Consumption plan attached to it, but it also has VNet integration. So this linking to the VNet here is VNet integrated, and then it's sending to event hubs through that event hub private endpoint. So HTTP is open to accept any requests, but then sending it to event hubs, the event hubs is locked down to private network with private endpoint. And we also have, I can probably show you here, let me find it. I'll go back there. One thing that I wanted to show you as well is we built in to functions, but also Flex Consumption, an easy way to performance test, load test your solution. If you have Azure, if you've used Azure load testing before, this is basically an easy integration into Azure load testing. So you can go here under performance and load test. You'll see I've run a few load test profiles already from this interface. So any function app that you have now should have that load testing one. And for Flex Consumption, we also have a thing called Performance Optimizer that allows you to configure multiple instance size and concurrencies to help you determine which one is the best for you. You might not care about how many instances get used, but you just wanted to handle 30,000 requests per second, for example, for your solution specifically. Then you could work with this Performance Optimizer to find the one that gives you that right amount of concurrency and instance size. And I kicked off a load test before. It probably finished by now. Yeah, it looks like it's done. Just before we started the session. So the throughput was about 30,000 requests per second there. As you can see, it used 5,000 virtual users, and the aggregate here, it went up to 58 at times. So that the 30,000 was the average, but it kind of stayed around the 58,000 requests per second. And it's not reporting any exceptions. Maybe one of those requests failed out of the 9.07 million requests that were sent. And to visualize what Flex Consumption did in the backend, I set up this test to not have a preload time. So it created the instances that it needed to start sending load, and then they all started sending load at the same time to Flex Consumption. And I'll just run this. Let me see if that has that. I think I have the right date here. So this is just a query in App Insights that will give me the number of instances that were processing requests for that performance load. I quite like this. I don't know if you've seen it before, but this make series here, it helps pad with zeros when there's nothing. Otherwise, App Insights does a straight line from when there's activity to the next time that there's activity. But this properly zeroes out when there wasn't any. So just to show here, what happened behind the scenes with App Insights was we went from 0 instances off that app processing requests, and then quite quickly, let's see, 250. Well, that was right on the dot. 250 0 to 20. So in 20 seconds, the app had about 122 instances processing messages from that HTTP request, and I have the default. I didn't change the default of the 16 concurrency per instance. So each instance was given 16 executions to handle. But of course, each execution is less than a second. It lasted less than a second. So for each second, each instance processed a few requests. So that's why it only needed to go up to, I think it's stabilized at 128 instances here. And then once the load test was done, it kills off all of the executions, and it quite quickly, there weren't any instances processing. You'll notice that there's about, for the real scale in, we still wait a couple of minutes before we start actually scaling in the solution from the backend. But as far as instances processing, it went straight back to zero when load test finished. So that's, and currently, I'll probably cover that, the number of instances that flex consumption can handle. So hopefully that makes sense. Customer feedback coming in, HTTP into the Azure Functions, sending to event hubs through the VNet, and handling, in this instance, it was about 58,000 requests per second, quite easily. Of course, there's the only delay inside the function is sending to event hubs. I wasn't doing any real processing there, but the app you could change the concurrency and get your app to scale even further if you need. So that's the So here's another example of concurrency impact. Say, for example, if you ran a few load tests with different concurrency instances, we ran here 3 tests where we had concurrency at 4, at 8, and 12, and 16. And you'll notice that concurrency at 4 for this specific app handled a lot more requests per second on the average. I think that's probably a P90 of 33,000 requests per second. The 8 was 19 and 16 was 15. And then there's a cost calculation here. We have a blog post that goes into this a little deeper. I have it on the resources at the end. But you can see that, of course, there's price difference that you will end up paying. The more instances that you use, you end up paying more. So the default of 16, in the end, it was about 15 cents US for this run. And with the 4, the one that handled the more number of executions per second, it goes up to 22 cents. It might not be a big difference in it, just a few cents here, but in the big scheme of things of running this every day, it kind of adds up. So you need to just make sure that you handle or have the right concurrency set for what you need. So say, for example, all you needed to handle was, at the most, was 18,000 requests per second. Then with this run, you know that the concurrency of 8 will be good enough, and you're not going to have to spend as much as the concurrency of 4. But we do have some really smart defaults already in the solution. So the default is 16 for .NET. For Python, it's 1 because it needs to handle 1 execution in each instance. And all the other ones are similar to C# as well. So for the 2 gig instance, it's 16, and then it goes up for the 4 gig because it can handle more at the same time as well. All right. So a bit behind the scenes here, how do we achieve this type of HTTP scaling in flex consumption? There's a few terms here that is just internal of the platform, but we have a front end. There's a load balancer, the Azure load balancer that we use in the platform. That HTTP request gets routed to the front ends from the load balancers, and then those front ends will send those events to workers. Antares is just a platform behind app service, so it's basically app service. So instances in app service that are hosting either the consumption or the premium plan, or this is not for app service plan because that scaling is different. And basically the front ends just ping those workers to check, hey, are you doing good? Are you healthy? And the workers might start, if they delay too long to reply, or if there's a few times where it replies with an exception on that ping, then the front ends decide, oh, I think I need to scale out this guy. And it sends that decision scaling to a data role, which is another platform component that knows where and how to add instances to a worker, to a function app. And then it does that by adding or removing them between 1 and 4 at a time. Most of the time, it'll just do 1 at a time. So if you do a load test on premium or consumption, you'll notice that the scaling goes a little slowly, but it gets there eventually. It just takes longer to get there. With flex consumption, we made a few changes. The first thing is the backend, like I mentioned before, is a shared platform that we have with container apps. It's called Legion. there's a blog post as well on the apps on Azure. I have a link to it later as well, but there's a blog post that talks about Legion in more detail if you want to check it out. But basically, the HTTP requests go through the same path, your load balancers and front ends. But because now we have this concurrency-based idea, our front ends know the concurrency that you chose for your app. And it knows then from the data role how many instances are already allocated to your app. And based on that, it then sends that decision saying, hey, there's a lot more requests coming in than what the number of instances are based on the concurrency that the app has configured. So give me a bunch of instances, and then it adds or removes those workers but based on that. And it can do it in batches. It can say, hey, give me 100, give me 50, right? And then the same way they keep track of traffic, and then we'll scale in as well. Another thing that we do to make sure that your app is very efficient, and this happens also in consumption and premium, but we basically have placeholder pools, which is, say, if you chose .NET 8 isolated, then there's a pool of instances that are already preloaded with the host and that worker for you in the Legion, amount of stamps that we have. And when your app scales out, it gets special, or maybe even if you scale from 0 to 1, it's completely not scaled to 0, and an execution comes in, it'll scale to 1. It'll take one of those instances from the placeholder pool, and it does a thing called specialization, where it basically tells the host, hey, load this customer's code and specialize this to that app. So then it does the VNet integration if it has to for the instance. It'll load your code into the worker so that it knows which code to execute, and loads any identity. So if you have managed identity configured, then that's the whole specialization. And that's what you see in cold start. That's all happening there. So at the moment, our cold start for .NET 8 we're seeing about half a second. That's for an empty app. But that's all that is doing for that time is specializing. And you can see when, say, if you're scaling to 50, 1,000, 100, then all of those are specializing, then starting to handle the requests. Moving on to networking, that's the next big thing. I've already kind of covered how it scales. And maybe there's some apps where you don't even need scale. I just need to handle one execution every Saturday to run a bunch of batch execution jobs, and then I'm done for the rest of the month, right? So that happens as well. But you want that function to both come up when it needs to come up and execute, but also connect to VNet. So not all flex consumption apps have to be scaling apps, even though that's a big part of it. But networking was the other part of it. So it pretty much has all the networking features that you have in the app service plans or Elastic Premium. The only difference is anything that is specific to Windows. There's a couple of older networking features of app service that only work on Windows that you don't have here. But those are a little older, and most people don't use those anymore. It's still serverless, so the VNet integration will work regardless. And I have a diagram that explains that a little bit more. And the key thing, I guess, here is no extra cost. So there's no change of cost for the VNet integration as part of it. You're only paying for the compute as it scales and executes functions. And then finally, inbound and private and service endpoint. If you want to really lock it down to only the network, both inside to call your function, but also for your function to trigger from event sources that are in the network, then you can do both. VNet integration to reach things into the network, and then inbound private or service endpoint for the other side. Cool. There are, I just want to call out a few changes in VNet compared to the other ones. The subnet must be delegated to Microsoft.app/environments, and that's because of that Legion sharing that with container apps. That's the delegation that is required for this platform. Each function app will consume at most 40 IP addresses, and this is a key thing. For an app that can scale up to 1,000 instances, in Premium Plan, each each instance of the app kind of takes one IP address when it's VNet integrated, and app service plans as well. And there's some companies that are pretty starved with IP addresses. The networking, there's a whole council of people that will give you one subnet with very few IP addresses. And flash consumption, we've done quite a lot of work. And if you read the Legion blog post, you'll see that there as well. But we've created a custom driver to allow the VNet connections to be shared per multiple instances of the app. So that means that your IP addresses, even if the app scales to 1,000, it'll use or calculations at most 40 IP addresses. This could change over time, but that's the current one. So if you have an app that doesn't scale at all, you could even go with the smallest subnet size that you can think of, and it'll still work. There's 3 IP addresses that get used, but everything else is used for your apps. And then we've done some testing as well. There's a blog post that I'll link to where we go over the with and without VNet with load testing, and we've noticed very little overhead. There's about, on the 50th percentile, there's only 37 milliseconds of difference of having that VNet integration with that or not having it. So we ran the demo that I showed you before with the HTTP to event hubs when we had event hubs behind the VNet and with VNet integration, and then without. And that's the difference that we noticed here. So very little overhead if you have networking configured. And then finally, there's a bunch of site settings and app settings that apply for other hosting plans when VNet is concerned that don't really apply to flash consumption. Just want to keep in mind as if you're migrating apps over and et cetera, and you have a bunch of networking related app settings or site settings like VNet route all, you don't need to use those because they're not required for flex consumption. It'll just always route all anyway. And for the scaling with networking is an interesting one. So for consumption, there's no VNet support at all. So basically, the scaling is just a regular scaling based on the event source. For premium, there's always one instance there, right? As you know, if you've already used premium or app service plan, it only scales down to 1, and you're always paying for that one instance. And that instance is what monitors when it's VNet integrated and it can access, say, Service Bus. That instance is the one that then tells the scale controller, hey, I need more instances. So it kind of flips from what we saw before where the scale controller or the front ends are monitoring to the instance itself being behind the VNet monitoring those event sources. It's called runtime-driven scaling. The flash consumption, because it also scales to 0, then we had to come up with a way to solve this where it scales to 0, but also can monitor those VNet integrations. So we introduced an internal component called Trigger Monitor, and that kind of always sits there when you have your app. It's always checking the event sources, but from inside the network. And Trigger Monitor will persist even if your app is scaled to 0. So basically, your instances, the app orange circle there, they'll be in your VNet, but also the Antares and Legion networks, so that it has access to all 3 sources. Scale controller can reach your app, but then the trigger monitor is the one that has managed identity and networking connections into your data source, like say Service Bus behind the VNet. And it tells scale controller, hey, I need to scale, and then it scales. So it's basically the same code that is in the front ends that we saw before. It's also running in this trigger monitor inside the VNet and specialized to your app. And then it votes to scale out. It scales out your app, and the app also has all of that VNet and managed identity that you configured, and it can trigger from Service Bus. All right, so let me see if I can show you here real quick, or maybe not. But I have another app. It's another sample that we have. Let me go here. So Service Bus triggering, and you'll notice that this Service Bus, just like my just like my event hubs from before, it has VNet configured. So, sorry, here we go. I'll go into it in settings, networking, and we'll see that this service bus is also, completely closed off to the public network, but it has a private endpoint. And even I think if I try to go to one of the queues, the queue here, and try to go to Service Bus Explorer, it will complain saying, hey, it has networking disabled, so I can't access it. You could, of course, I could add my IP address to the service bus and then be able to send messages in there. But for this demo, what I have created is just a virtual machine that is in the same network, and then I can use that to send events to the service bus. Okay, let me see if that's still there. Nope. I'll just get the user from the sample here. All right. All right, we're in. So this is a virtual net machine that's inside the VNet. I don't know if you've seen this before, the Service Bus Explorer is just a way to connect to Service Bus event hubs. It's an open source app out there. But basically, here's my queue. I'm sorry, this is a little small. Let me see if I can zoom in a little. Yeah. So my service bus there is empty. Let me refresh. There's 0 instances there. So I can right-click and send messages to it. So hello from VS Live. I'll send, let's say, 50 count of messages there. And then I'll start sending. So it basically already sent 50 messages to my app. And we can see here, if I refresh, that's 50. And it's gonna wake up my app, get it to process those. So in a few seconds, it's gonna process them. But the reason why they're staying there for a while is I wanna show you here, the code for this app is a Python app. So I have the concurrency set to 1, and I'm sleeping for 30 seconds. So basically, it's gonna go from 0 to those 50 messages with one instance processing each message, and they're all waiting for 30 seconds before they complete and remove that message from Service Bus. So I'm not sure if 30 seconds have gone through already, but that's, yeah. So now it's back to 0 and they all got processed, right? So that's just to show another concurrency with messaging, but also networking support for flex consumption, where it's completely inside the network. Cool. So have some time still. The next topic to cover, and I know it's quite a lot, but it's I really want to go into all the features. Well, another thing that we implemented, it's kind of done for you, but you should be aware of it, is per function scaling. We have 3 special cases: HTTP, the event grid-based blob trigger, and durable, where they will scale together. So all the HTTP functions that you have in your app will be put into the same instance, and they can handle any of those requests that come through, and it'll scale that way based on the concurrency, because the concurrency for HTTP is just one setting. But if you go into, say, event hubs or Service Bus or Cosmos or Kafka, then each function might be pointing to a different queue, and the number of messages going into that queue is different. So the scaling decision will be different, or at least the scaling votes would be different. So that's why we created, to ensure that we're deterministic with the scaling and the concurrency, we created this per function scaling where, say, if you have 2 Service Bus functions inside your app, you don't have to change how you created your app. Your code remains the same. But the way it scales behind the scene is each one of those will be given its own instances to scale out to and into. So that, if one queue might be super busy, the other one might not be. So one is scaled in and the other one is scaling out. And they all still count towards the max instance count of your app. So you need to just be aware of that. And last demo that I have here, just to kind of showcase one more thing. We made a decision for Flex consumption, at least for now, to only support the event grid-based blob trigger. There's a little more configuration that you need to do to get that trigger to work with event grid. But once you have it running, it is very fast compared to what the blob trigger used to be. I don't know, we've had a lot of customers complain that, hey, there is a blob that showed up in my blob storage account or container, and it's taken it 8 minutes or a few seconds, depending on where in the process it was, to process that message. So because flex consumption is meant to be a fast and quick executing and scaling service, we are supporting this event grid-based blob trigger first. So what I have here, just to show another, I guess, language support here, we have this blob PDF simple, and it basically creates two containers, unprocessed PDF and processed text, and it will process that PDF to text. So it's this one is a Node app. So the PDF processor here, I'm using pdf.mjs as the package there, and it basically looks at a PDF, creates the text or extracts the text out of it, and then it's going to write out to the output container. Another thing that we've created as part of the functions extension here is you can now test this out locally without really needing event grid. So you can go into once you start debugging. Let me see. Oh, I'll have to open that folder. But once you start debugging with Node.js here and the Azure Functions extension, then you are able to put messages into the local emulator, the Azurite emulator, into the unprocessed PDF, and then right-click on the function and say execute it, and give it the name of that blob that you uploaded, and it'll run it locally just as if it had received an event grid message for that blob once you deployed. So I've already deployed this to Azure here, so let's have a look. Blob. Here we go. So there's my function, and there's the storage account. And this is the event grid system topic that got created for that solution. And let me check. Under blob services, this one doesn't have any VNet, so I can actually go into and check out. So I'll delete all of these processed ones, and also the unprocessed ones. So there's no files in both of the containers, and I can now upload a bunch of PDFs here. Let me find where they are. Code samples. End-to-end blob data. All right. So I have about 6 of them here, 7, and all 6 files, and I'll upload them. They're all uploaded, and then under process text, it'll already be showing up and all processed, right? So that's the key thing for this event grid based blob trigger is the blob trigger itself in your code. It looks pretty much the same. There's nothing that changes here. So this is Node, and that's just saying it's a blob trigger. The other thing I changed here in the code itself is to say that the source is event grid based, but it basically gives the app that contents of that blob instead of you having to go and fetch the blob from storage like you would do with a regular event grid trigger. And you could, of course, you saw here, I barely had time to switch over to the other container, and it's already all processed there into text already. Cool? All right. Get in there. One other topic for flex consumption is called always ready instances. This is a term that we copied over from the premium plan as well, but it basically, you can tell the app to always have specific number of instances up and running for your app and for your trigger to handle any executions. So if you really want the minimal code start, or if you want to handle a burst super quick at the beginning, then this is a good idea to configure. It's called always ready. And of course, if the concurrency and instance size happens to go above what those always ready instances can handle, then it'll keep scaling up to your function app maximum scale out using on-demand instances. So it goes, always ready gets the first executions, and then beyond that, it scales out to on-demand. We're currently in public preview with flex consumption. The regions that we have are there. We're working on a few more regions, probably post-GA. And the runtimes, one thing to call out there is just .NET 8 is the isolated mode only, even though we just released in-proc for .NET 8. For flex consumption and going forward, it'll be just the isolated. So if you're on that journey of migrating from in-proc to out-of-proc, flex consumption handles the out-of-proc isolated one. And I have a slide on GA later on, so I'll get there. One more thing to be aware of if you're working with flex consumption is, even though each app can scale up to 1,000, at the moment, we have a regional per subscription region pair max of 250 cores or 250 or 512,000 megabytes, which kind of means 250 of the 2 gig, but you can mix and match apps of different memory sizes. And once they reach that 512,000 megabytes, they'll stop scaling. But this is a soft scale limit. You can always raise a support call and ask us to increase your function app or your region subscription to get more access. So if you really do need to go to 1,000, 2,000, 3,000 instances, then just reach out to us and let us know. And that's just an example, a real example of an internal customer. They were processing data from Cosmos from a queue into Cosmos DB and doing a bunch of transformations. And the app was started scale to 0. It reached 250 limit. That they got in contact with us. We raised their limit to 1,000, and without them having to change their app at all, it just went all the way up to 1,000. And then there were 1,000 instances of the same flex consumption app processing messages from their queue and writing to Cosmos DB. There are some control plane changes. That's not as interesting, but all of our samples, of course, have this in Bicep that you can check out or ARM. But we did a lot of work to require as few app settings as possible from you. And what made sense, we moved them into the proper control plane, into what you put into ARM or Bicep. But if you're using Azure Developer, AZD or Bicep or AZD or the Azure CLI or Functions Core tools or the portal to create your apps, any of those dev tools, they already know how to do this behind the scenes for you. But it's only if you're writing your own ARM or Bicep templates, then this is very important to be aware of, including the deployment storage. So basically for flex consumption, there's a new requirement for you to give us a blob container for your app package to be saved to. When you do a zip upload or a deployment of your app, then it'll save it to this container. Typically, all of our samples and all the current tooling will just reuse the same storage account as your host storage account, the Azure Web Job Storage one. But you might want to, I want to own and separate a separate storage account just for my package content. And then you can do that by configuring this. And then you can use either user assigned, system assigned, or a connection string to your storage account. I would recommend going with the identity ones nowadays because it's more secure, but connection string also works. One more topic, maximum function execution. Similar to the premium plan, we removed from the host any limitations. At the moment in consumption, when I think 10 minutes is the max amount of time that a function execution can run for. But for flex consumption, we basically follow the other hosting plans and remove that limitation from the host. You still have to be careful and aware that the platform might interrupt your function execution if it needs to do some patching, or if it's scaling in, or if there's things that you've done, like you deploy a new version of your app, those instance executions will still be stopped. But going further, we'll better document this as what are the actions that would stop your function from executing. And for HTTP, it's the same for all of app service functions. There's a limit of 4 minutes to 130 seconds there for inbound HTTP trigger execution. So if you need an HTTP execution to take longer than that 230 seconds, then send it to a queue, get another function app to handle it, or use durable functions or something like that. Getting close to the end here. So for billing, you probably have seen that number before, the on-demand execution time, 0.000016 per GB second. And that's because that's the same compute cost for consumption as well as the total executions at the bottom there, 20 cents per million executions. So it's exactly the same as the consumption pricing. The key change, I guess, that you need to consider is for flex consumption, this is the GB that for that calculation comes from the instance size that you chose. In consumption, we kind of do an observation of how much memory you've used inside that 1.5 gig instance size. But for flex consumption, because you choose the instance size, you say, I want a half a gig, I want a 2 gig, I want a 4 gig instance size. You will be charged when that instance is active for that. So it's basically, if you have one execution for 1 second on a 2 gig instance, you'd be paying that 16 times 2 for that 1 second, right? I've already covered this. Just check out the integration with Azure load testing that we have. It's quite cool and pretty easy to set up. This only works for HTTP though. If you want to do other trigger types, then you would have to go to full Azure load test and use either Locust or JMeter with the trigger sawyers and set all of that up yourself. But for HTTP, load testing is the integration is really great. Just to cover roadmap, this is probably my second to last slide. GA, we're currently on track to GA this in November at the Ignite conference. Post GA, or even at GA, we're still working out which features will make it in or not, but there's the half a gig instance size that I mentioned a few times. Availability zone support. For availability zones, the implementation will require always ready instances configured. So you need at least 2 instances of always ready configured, and we'll place them there. That's for guarantee. And then as it scales out, the app will still use the zones in the region for regions that we support zone for. Slots, deployment slots. So if you use that, we're working on an improved version of deployment slots for flex consumption. And that's why it didn't come in when we already public previewed, is because we're trying to improve a lot on it. And then finally, .NET 9 support, because it's coming quite hot. And then improve deployments with better observability and validation. So this is one, we're creating another internal component called the Functions Deployment Manager, that when it kind of detaches from the actual host and kudu deployments, and it'll help and make sure that when your app is deployed, it's fully deployed and everything is working before it gives an ACK to the client to say, now you can run this app. Currently, you have to go into App Insights and figure out why the deployment failed, or in the kudu logs and etc. So we want to improve on that quite a lot. And one of the last slides here is we have a case study with GitHub. I think there's a blog post coming out pretty soon, but they came to us. They are processing. They process about 700 terabytes of data a day, which is very heavily used for malicious behavior against their infrastructure, so internal logs and etc. And they had special event hubs where they were processing from using a solution that they built on Kubernetes, but they wanted to take advantage of paying for compute as it scales out and in. On the weekends, things went down considerably. they had too many of these different regions that they were trying to handle with only one, that they wanted to break it up into regional implementations. So when they heard about flash consumption, we started working with them on this case study. And it basically is that example that we showed before, but reversed. It's triggering from event hubs and then sending over HTTP instead of HTTP to event hubs. So it's getting all the telemetry and then sending it out to a downstream system to process that data. And with one function app, we were able to scale it automatically to about 900 instances, and it was sustained 1.6 million messages processed per second from event hubs and into that HTTP endpoint. So it's kind of an extreme case here of scale, but that's why we built, one of the reasons why we built flash consumption is to be able to handle anything from 0 to 1.6 million messages in this case. So here are some resources. If you're interested in flash consumption, you want to learn more. All of the demos, those 3 demos that I did, are in the samples one at the bottom. There's a public preview announcement there that has more information. The blog post that I called out, where we showcase, running multiple concurrencies, the things that you can do to improve the high HTTP scale is there. The full documentation, and then more a blog post about Project Legion as well. And I'll share these slides with the conference organizers, so I think they let you know where the slides are later. Cool. Finally, just make sure that you provide some feedback. I'd be glad to hear your thoughts on how the session went, what you're thinking about flash consumption, and how you like this conference overall. But that's all I had. We still have a few minutes. If you have questions, I'm happy to answer questions here. Or
what's your best guess on flex consumption availability in the government regions?
We're still working on the public regions, but we've got some requests for government ones. So that'll probably be the next batch sometime, maybe next year. Yeah. But I can't tell you exactly when.
I'm not asking you right.
Cool. So the question was availability of flex consumption in government cloud regions. Yes. Right. So Azure DevOps support for flex consumption, right? The published task. Well, I have good news for you. Just this week or late last week, we updated the functions publish task to support flash consumption. You'll notice the documentation just got updated yesterday, and there's a tick box. Once you choose the Linux, that it's a Linux type, there's a tick box that you'll say, this is a flash consumption app, and then it knows how to publish to flash consumption. Cool. Anything else? Flash consumption is awesome. You're going to test it out. You're going to tell me, and you're going to fill out the survey. All right. Thanks, everyone. I'll be hanging out here a little more. Thank you.